Hello and welcome to part 87. In this video, we will see what are shared resources and how we can protect shared resources when working with threads. Let's first understand what are shared resources and what can happen if we don't protect them. So here I have a variable integer that is defined at the class level, right? And it is a static property, correct? So what I will do, I have one method increase by 100,000. So I will increase this number by 100,000. Let me call increase by 100,000 one time and increase by 100,000 second time, right? And then I will print the result, right? Okay, so we are running it without any threads. Once this execution is completed, then only we are starting the next execution. So when we run this program, you will notice we will get 200,000 because we have increased 100,000 two times. If I run my program again, I will again get 200. And if I run my program again, I will again get 200,000. So my result is very predictable, right? But let's see what will happen if we run the same execution using threads. Okay. So I will uncomment this piece of code. So what I'm doing, I'm creating two threads, right? Thread 1 and thread 2. And I'm starting these two threads here and I'm waiting for these two threads to get completed using the join method, and finally I'm printing the output. If I run my program now, you will notice I get 200,000. If I run it again I get 200,000. But this time I got some less number, right? And if I run again, I got some different number. If I run it again, I got some different number. So what is happening here? Because the total number is a shared resource, both the threads are trying to increase the same number, right? And this is causing the confusion here. Let's see what is happening exactly here. When we are running sequentially, the total number is 0. Then the thread 1 will read the number and then it will increment the number. Then the second thread will read the number 1 and then increment it, meaning we will have 2 at the end when it is sequential. But when we are running the two threads in parallel, what will happen? The value is 0, thread 1 reading the value as 0. Because thread 2 is also running, thread 2 will also read the value as 0, right? So both the thread having the value 0. So when they will do the increment operation, meaning when they will do total plus plus, they will increment on 0, right? That's why the final result of the value will be 1 by thread 1 and 1 also by the thread 2. Ideally, the number should be 2 because we have performed the increment operation twice. So the total should be 2. Because we are running the two threads parallel, that's why we are having this issue. And the number is not incremented properly here. So now let's understand how we can resolve this issue. So it can be resolved by two ways. One, by using interlocked. Let's see what interlocked means. Interlocked is a class that can be used. Here I can say interlocked dot increment and I can pass the reference of total. So what will happen when I use this interlocked class? It will allow only one thread to read the value and update the value at one time, so that we will not have that issue that we were seeing here. So only one thread will read the value, it will lock that value, and until it has not released that value, other thread cannot read that, right? So if I run my program now, you will notice I will get 200,000 every time. I am running it second time 200,000, third time 200,000, fourth time again 200,000, because now interlocked is locking the total variable and not allowing the other thread to do the manipulation on this variable. So interlocked is one way to protect our shared resource, that is nothing but the total variable to be accessed simultaneously in multiple threads. The other way is using the lock mechanism. Before going to the lock mechanism, let's first see what are the other operations that are available in the interlocked class. So when we are using interlock class, right, it gives us a lot of methods. So we can use increment, or exchange, read, add, and equals. So it has a lot of methods. Using that we can make our shared resources protected. So now let's understand the lock mechanism. To apply a lock, what we need to do, we need to create an object of object type. So let's create it as public static object. Let me call it underscore lock equal to new object. Okay. So this is our lock. Our lock is created. Now let's see how we can use this lock. Let's remove the interlock class here and make it total plus plus, just like before. So what we need to do, we need to lock this below line using that lock object, and we need to put all the code which is working with the shared resources inside this lock. So what effectively will happen, this lock will allow only one thread to go inside this line and increase the value of total variable, right? Let me run it again. You can see here I'm getting the correct result, 200,000, again 200,000, right? Even if I increase this value to 200, let's see, we will get the 400,000 or not. 400,000, right? Again 400,000, correct? So using lock mechanism, we can also achieve the same thing, but this allows us a lot of flexibility. Using interlock class, we have the limited access to the methods, right? But using lock mechanism, I can do a whole lot of operation on my shared resources, and it will be always thread safe. And that's it for this video, guys. In the next video, we will understand the difference between monitor and lock in C#.